All right, can everyone hear me okay? Can you hear me at the back of the room? Yeah, good? Okay, fantastic. So I just want to make sure that everybody is in the correct room. Everyone here is ready to learn about infrastructure as code with NXOS and NDFC and covering Ansible topics, right? We're good. Okay, fantastic. So I will say this year, this slide is a little bit lonelier than normal. My name is the only one that's up there this year, but normally I present this session with a colleague of mine, Matt Tarkington, and we collaborate together on building a lot of this content, a lot of the automation solutions we develop together. And so I will say this, though, it leads nicely into this next part where I force you to join the WebEx session so that you can collaborate with us. Matt Tarkington is actually one of the moderators, and so he's going to be helping answer any questions that you might have, and we look forward to collaborating with you in that environment. We'll keep it open until February 28th, so please post your questions if you have any in there, and we will work through those. All right, so what is our agenda today? So first of all, we want to define what is infrastructure as code. I know this can sometimes be a confusing thing to define because there's a lot of definitions that are floating out there. So we're going to try to come up with a common definition for what is infrastructure as code. Then next, we're going to move into infrastructure as code with NXOS and Ansible. Now, I do want to pause for a moment and just, by a quick show of hands, who would consider themselves really a rookie when it comes to Ansible? Okay. Who are my Ansible experts? I just want to kind of get both ends of the spectrum. Any Ansible experts in this room? Okay, fantastic. So I will say that I'm going to use the infrastructure as code with NXOS as Ansible as an opportunity to do a little bit of a primer on Ansible. I want to make sure that everybody in the room understands how to use Ansible and how we start to use it for networking devices specifically. So everyone's going to put their Net DevOps hat on today. Everyone's going to become a Net DevOps developer, and you're going to walk out hopefully with a set of skills that you can get started or continue your journey for whatever that may be. When we move into the infrastructure as code for NDFC and Ansible, we're going to hit the turbocharge button a little bit because we're going to present an entirely different approach to automation. I'm excited about sharing a solution that we've been working on that allows us to drive the configuration intent into your VXLAN EVP and fabrics using a data model approach. So I want you to remember data model. If you don't get anything out of the rest out of my session today, remember that we want a data-driven approach when it comes to our Ansible. And so that's what we're going to talk about today. All right. So I want everyone to get up, and I want you to come up here, and I want you to give me what your definition of infrastructure as code is. It might get a little awkward because you're going to have to kind of talk into my microphone here. But so everybody stand. No, I'm kidding. We're not going to do that. So ultimately, it's something that is difficult to define for some people, and so I want to make sure that we are all on the same page when it comes to infrastructure as code. So the idea is, raise your hand if you save your configuration intent in text files or spreadsheets. Just want to see a quick show of hands. Anybody use those in the past? Okay, so that's it's a common thing to put your configuration intent into one of those mediums, but the idea of infrastructure as code is we want to start moving towards something like YAML, which is more of a structured format for your data. And now this is not specifically tied to any automation technology like Ansible or a specific programming language like Python. It's just the idea that you save your configuration intent or your network code in some type of source code repository like GitHub or GitLab, and that allows you to version your changes and make sure that you understand what's changing across your fabric from change to change. Now, what that nicely leads into is the idea of building pipelines. All right, so another question. Who in this room is already building CI/CD pipelines? All right, nice. Okay, we've got quite a few hands that went up, more than in years past, which is great. So what we represent here is a basic CI/CD pipeline. So if you're not familiar with it, in step one, the user, you the operator, you the NetDevOps engineer, will commit your configuration intent, usually in some structured YAML file that describes what configuration change you want to make to your fabric, okay? So in this particular case, let's say we're talking about a VXLAN EVPN fabric, and you want to add a network or a VLAN to that. So when the GitLab runner or the CI/CD pipeline environment detects that change, it will kick off a series of runners to apply that change. And what we recommend is that you actually test and verify that change in some type of a safe staging environment before you push to production. So this is a great use case for Cisco Modeling Labs or N9KV, where you can build out a topology that, hopefully mimics as close to possible your production topology, but it's not lost on me that that's not always possible. In fact, it's rarely possible that you can match your staging environment with your production fabric one-to-one. So you need to come up with some subset of tests that you can run in that staging environment so that you can have a higher degree of confidence that when I push my change to production, I'm not going to break anything. Now, you notice the dotted line there. So who's comfortable? We're talking about continuous integration. That was the first step. And then continuous deployment or continuous delivery. So who would be comfortable if your test passed, just let it go and push to production? Anybody in this room comfortable with that? Ah, fantastic. We have some brave souls out there. That's great. No, ultimately, we want to get to that point, right, where we can trust our tests and things just push to production. But typically, we do that during a change window. And so that's why we have that merge window where a human being can inspect the results, make sure that everything looks good, that those tests passed on your staging environment before we push things to production. And those same runners will kick off and run the same set of tests, and that completes a typical basic CI/CD pipeline. Now, every pipeline is a little different, potentially more complex, but these are the basic building blocks for every single pipeline. All right, so let's switch over now that we understand this idea of infrastructure as code, we've defined it, we understand the building blocks for a CI/CD pipeline. Let's talk about infrastructure as code with NXOS and Ansible. Now, I know there's a lot of people in here that might just be starting their journey with Ansible, so I'm just going to quickly go through a few slides that describe what Ansible is. So it's an automation, configuration, and orchestration tool. Now, I don't know if you've ever used Puppet or Chef, but typically, historically, those started out as agents where you had to install those directly on the devices. Ansible gained in popularity because, for one, it's a low barrier to entry. It's very easy to pick up. And the second piece is that it uses an agentless model, right? So it pushes to the devices from a central control host. Now, one really important piece that I want you to understand is you don't have to be a programmer. If you are a programmer, like if you love Python, I personally love Python, it will enhance your ability to extend and customize Ansible. Ansible is built on this idea of a plugin architecture where you can write your own control plugins, you can write your own modules, you can write your own action plugins. There's all kinds of plugins that you can write if you work in Ansible, or you can just use the ones that people have already written. What is really good for you to become savvy is working with data structures. So we're talking about, YAML lists, list of dictionaries, dictionaries of lists. So you can organize your network intent in a structured way and then use Ansible to push that to your network. All right. So very simply, you install Ansible on your control host. I install it on my Mac. I have servers in my lab environment. Any Windows users out there? Windows user? Okay. I think it might be time to reinvest, so save up and purchase something new. But there is WSL, so that's a good option for Windows users. But there's also some graphical user interfaces if you want to build your Ansible workloads around Ansible Tower, or the enterprise project called Ansible Automation Platform. Those are also great options for defining your Ansible workflows. Once you have installed Ansible, now, the first thing that might pop out to you is you're like, hey, Mike, didn't you tell me that I didn't have to be a programmer? And Python is one of the big, blue, bold things that pops out at me. Well, we do have to install Ansible on the control host, but you don't necessarily need to know how to program in Python to use Ansible. So when we install Ansible core, that gives us the basic building blocks we need to execute Ansible automation jobs. But now we need to install some additional collections for the specific technologies that we want to manage. So obviously, we're dealing with NXOS today. We also include built-in, that's part of Ansible core. We include that because we're going to save some data state and do some interesting things with Jinja 2 later, and so that's why we introduced the built-in collection. But we also have the DCNM collection for NDFC and NAC DC VXLAN. That's our solution collection for driving our VXLAN as code solution for NDFC. So we'll talk more about that later. And then finally, once you have your collections installed, now you can start to develop your playbook code, your Ansible code, the tasks, the organizing those tasks into roles to make them more highly reusable. And then you define your targets, your inventory. I want to configure NXOS devices. I want to configure my NDFC controller which fans out to various NXOS devices. So there's 3 primary ways that we configure an NXOS device. We can go CLI commands over SSH, where we're literally just passing CLI commands to the device. We can go over netconf. Now, we're not going to cover netconf today. We can also use the native DME model, but that's not something we're covering in today's session. So if you have any questions about that, I'd love to talk to you after the session today. There's also a REST API where you can, or a REST-like API where you can pass CLI commands. It's called NX API. Now, NDFC only provides a northbound REST API. All right, so you might be wondering, Mike, you have DCNM as one of the collection names. So why are you mentioning DCNM when we're talking about NDFC? So this is also a good time. Raise your hand if you have or are using DCNM today. Anybody in the room? Okay, fantastic. Just a couple people. So NDFC is the rebranded version of DCNM. So it's been re-architected using a Kubernetes microservices architecture. I'm going to get more into that in just a few moments, but just understand that the old name of the product used to be DCNM. So if I had a pair of these hindsight tech specs, I could have looked into the future. These probably would have been infused with the latest generative AI, and I could have known that we were going to rename and rebrand the product as NDFC. But at the time, I picked the best name that I had, and that was DCNM. So we're stuck with DCNM for now, but just understand that if you write a playbook for DCNM, it will also work for NDFC. All right, so when we install Ansible, there's 2 primary ways that we install Ansible. You can install it using pip, which is the Python package manager. So you can use Ansible core, which is a smaller footprint because it doesn't come with any additional collections. It just comes with the base pieces that Ansible needs to work at a basic level. Now, once you install it, you can go and pick and choose the collections that you need. And the nice thing about that is you can ensure that you've got the latest version. So if you want the latest version of the DCNM collection or the NAC DC VXLAN collection or whatever collection you want, that's probably the preferred method. If you do a pip install Ansible, you are going to get this batteries included approach, but that just includes a smaller subset of community curated collections. NXOS is one that's included in there. It is a larger footprint, but you also need to realize you don't necessarily get the latest version of those community collections. So my personal favorite is just pip install Ansible core and then pick and choose the collections you need so you can get the latest version of whatever you need. Or maybe you need an earlier version. You don't want the latest version, so that's okay as well. All right, so just a quick word about Ansible collections. They were introduced in Ansible 2.9. It used to be that everything was baked into the Ansible product. When you said batteries included, that everything was included. So they moved to Ansible Galaxy being the primary delivery vehicle for collections. We also have this thing called certified collections, which is available on Ansible Automation Platform. I'm not really touching on that today, but that provides an extra level of certification and Red Hat support if you want to use a certified collection. But most certified collections are also available on Ansible Galaxy. So the nice thing about this is that you're not tied to Ansible Red Hat's release schedule. For example, I maintain, or my team maintains, the DCNM/NDFC collection and the NAC DC-VXLAN collection. I get to determine what the release schedule is. So it's nice from that perspective. And there's some additional niceties in terms of flexibility. So Ansible Galaxy is the command that you use. So just like you use pip to install a Python package, to install an Ansible collection, we've got the command right here. It's Ansible-Galaxy collection install, and then Cisco dot whatever the collection name is. You can't install all three using the syntax I have there. I was just trying to save on slide real estate and show you all three of the collections that we're talking about today. All right. So if you've used NXOS, the NXOS collection, last time I checked, we were up to about 85 modules in that collection. Most of the collection modules center around specific features or specific capabilities of the NXOS device. So you've got modules to manage things like OSPF and BGP and interfaces. The documentation is actually quite good, and so you can go and see the different key value pairs that you can pass in to configure the different features on NXOS devices. And these modules are actively maintained. In fact, they're actually owned by Red Hat, but we also, with support from Cisco, because we work directly with Red Hat to support these modules. Okay. So let's look at the anatomy or the taxonomy of an Ansible module just really quickly. So a best practice is to always use the fully qualified collection name when you're calling or you're using an Ansible module in one of your task files. So in this case, you can see that Cisco is the collection namespace. We have a lot of different collections in the Cisco namespace for different Cisco products. You've got the collection name. In this case, we're talking about NXOS because we're going to direct-to-device for direct-to-device workflows. And then the name of the module, and this is the NXOS VLANs module. So one of the first things that might stick out is like, wait, there's redundancy, right, between the namespace or the collection name and the module name. Historically, we didn't have fully qualified collection names, and so the module name acted as a sort of namespace, and so that's why there's a little bit of redundancy there. But just know that all the different collections follow the same pattern. And then if you want to configure a VLAN, it provides the properties or the key value pairs in the documentation that you pass in. So this is an example of one where I'm passing in a VLAN ID with a value of 102. All right. So that's enough about Ansible concepts. We're going to switch gears now, and we're going to introduce a specific use case that we want to automate. So is anybody in here maintaining or configuring VXLAN EVPN in their fabrics or in their networks? Anybody? Okay, excellent. I want to know who my CLI warriors in the room are. Has anybody actually configured a VXLAN EVPN fabric by hand? Okay. Just give me an idea. Like, how long did it take you to configure that fabric? Anybody brave enough to tell me? Yes. How many? 3 weeks. Okay, fantastic. That's a long time. So as we kind of move into NDFC, we're going to see how we can reduce that time, down more and more. But when you start to leverage something like Ansible automation, I mean, it's still going to take a while to put together all your code to configure a complex VXLAN EVPN fabric. But hopefully with these tools, you can start thinking about how you can organize your automation around something like a VXLAN EVPN fabric. So if we actually, let me go back. There we go. So we're going to talk about 3 buckets, how we organize our automation, right? So bucket number 1 is common configuration. So this is where we want to configure things like host names, NTP, DNS, enable some of the VXLAN EVPN features that we need on the device, right? So these are things that we want to do across all of our devices. So this is our common bucket. The next bucket is we need a bucket for the underlay. This is where we're going to start to define the interface configuration, routing protocols. We want to enable BUM, multicast in the underlay for BUM traffic. So these are the kinds of tasks that we would need to automate in our underlay bucket. And then finally, of course, we need our overlay bucket. VRFs, VLANs, SVIs. So using these 3 buckets, how do we start to do this in Ansible land? So Ansible provides a well-known directory structure. So Ansible is very flexible, but this is Any Ansible project that you look at will typically have these core pieces configured or defined. So I'm going to start at the bottom. We're going to talk about what to do. So the vxlan.yaml file tells us what we want to do. Roles are a way to take those, what we want to do and make those tasks highly reusable. Remember, we want to write highly reusable automation. It's possible to write automation that works for one specific use case, but then it's not really useful for other cases. And so we want to start using roles, and we're going to dive into those a little bit more. In fact, let me ask, is anybody actually using roles in their Ansible automation today? Okay, fantastic, excellent. Now, I talked a lot about the fact that we want our Ansible automation to be data-driven, right? So we want to take advantage of Ansible's host vars and group vars to define the data that we want to describe the intent for our configuration. And then finally, the place that we want to execute our automation is defined in the inventory.yaml file, or we call it where to do it. All right, so let's jump into this. So at the top level, remember we talked about those three buckets. We have our common role, we have our underlay role, and then we have our overlay role. So the VXLAN main playbook defines these three buckets or these three roles in terms of where we want to execute this configuration. Now, where we want to execute this automation, so we're talking about going direct to device, and so we need to define the connection information for how you connect to an NXOS device. So the Ansible connection parameter, this is the parameter that describes one of the three flavors that we use to connect to NXOS that I talked about in the beginning. In this case, it's network CLI, and so we're going to be using SSH, and we're going to be sending configuration commands over SSH to the device. And of course, you have your username and password, and then the Ansible Network OS. That's a very important part of Ansible that describes which kind of device am I going to connect to. In this case, it's NXOS. When we get to DCNM, you'll see that that's going to change to cisco.dcnm.dcnm. Now, just for the sake of the rest of this lab, we're going to actually that's the next part of the slide. Let me talk about how we group things together. So we know that we have a VXLAN EVP and Fabric, and so we need to group our network devices into the groups like spine devices, and then also leaf devices. Now, for brevity, we're going to refer to the connection plugin here on out. We're just going to annotate that as network CLI just to save on some slide real estate. So if we put all of this together and start to look at these relationships, so we have our common role, our underlay role, where do we want to apply those roles? Well, you can see here that we need to apply them to the spines and the leaf devices. When it comes to our overlay role, we really only want to apply that to our leafs group. So you can see that Ansible gives you flexibility in how you describe or how you subdivide your inventory so that you can apply those roles based on your configuration intent. Okay. So we're going to kind of double click into one of our roles here. So this is going to be the overlay role. Now, Ansible Galaxy gives you a command. It's right there on the slide. It's Ansible-Galaxy init and then the name of the role. It will create the directory structure for you, and it'll create all of the template directories and additional directories that you need to fill out this role completely. So the main.tasks file or the main.yaml file under tasks is the entry point into this role. Now, this is how we are going to actually execute our automation. So does anybody remember that song in the 90s, This Is How We Do It? All right. So I want you to think of that song. So when you're reviewing these slides on the plane back home, that song is just playing on a repeat loop in your head. So you remember that roles define how we want to do our automation for a particular task. All right? So reviewing some of these roles again. We have our common role. That's where we want to configure host name, features, maybe NTP, DNS. We have our underlay role. That's where we configure our multicast, different protocols, our interface configuration, and then ultimately our overlay role where we configure VLANs, SVIs, VRFs. Now, we also need to manage the VXLAN tunnel endpoints, right? So we can think about starting to put some of the tasks around managing the NVE interface since we're dealing with NXOS. All right. So let's double click into a task file for the overlay role. So remember earlier, this was the NXOS VLANs role. It's one of the modules in the NXOS collection. You can see here that we are passing in our configuration, and we are defining all the VLAN to VNI mappings in that configuration list block. So, anybody see any problems with this approach? Does this look good? Head nods, maybe. So what's one potential problem with the way that I'm defining this task? Any thoughts? Don't do Ansible variables this way. I've actually hard-coded everything into the task, right? We want to write highly reusable automation. So if we hard-code everything into the task, this is not reusable. So how do we make this task reusable? Well, this is where the common directories in Ansible, by the way, just as an aside, Ansible provides like over 20 ways to define variables, and there's variable precedence, and so you can get in a lot of trouble with all the different places, and so I like to stick with, generally host vars and group vars, and there are some places within the role where you could also, define additional variables, but if we start with group vars, this is a way that we can say, look, I have a set of features and networks or VLANs that I want to configure across all of my leaf devices or all of my spine devices. And you remember we defined in the inventory file, we defined spines and leafs. And so just by naming the file leafs.yaml, that makes this data available to configure across all of my leaf devices. Now, at this point, you might say, well, okay, that's great for things that are common across some of your devices. What about host-specific data? Well, that's what host vars is for. So if you remember, under my leafs group, I had specific hosts. Now, this could be the IP address. It could be a fully qualified domain name. As long as you match that entry in your inventory file, you can make this data available to configure on all your specific hosts. And then when you run your task, you just point to a variable that sucks in this data from these files, and that way you start to make your automation highly reusable. So in this case, I'm configuring a specific host name, and I've got my layer 3 interface information in this file. All right, so let's kind of recap and put all this together. So in our inventory file, we specified our groups, our spines, and our leafs. Our main vxlan.yaml file, this is where we specified what we want to do. We want to do some underlay things, some common things, and some overlay things, right? And then we want to apply those to our spine and leaf devices. Now, when we define the specific roles, in this case, we're using the NXOS hostname file, NXOS hostname module in our common role, and then we're using the NXOS VLANs module in our overlay role. So this is the first time I've shown you how we start to make this task highly reusable. Remember, I'd hard-coded all my information in the task previously. Now I've got these little curly brackets, and I've got this name in between the curly brackets, and so that allows us to map this to our data file. So that curly bracket host name means I need to go to my host vars file for that particular host and pull out my host name from that file. And so you can see that happening here. And then for my NXOS VLANs, I want to pull out my networks from my group vars directory. And so I reference networks from my group vars leafs.yaml file. And then I start to loop through using an Ansible loop. I can loop through and configure all those networks against my network device. Now, has anybody used Ansible loops? Are they fast or are they slow? They're kind of slow. So I think of it like going to a grocery store and you want to buy some apples, right? So we go to the produce section. I want to buy 5 apples. I go and I buy an apple. I go back to the cashier. I pay for the apple. And then I go back and I get another apple, and I go back to the cashier and I pay for that apple. So besides making the cashier very angry or thinking I'm very strange, there's a much more efficient way to do that, right? I could take a bag with me, get all the apples at the same time, and go and pay for them in one single transaction. So going back and forth and getting the apples, that's kind of what Ansible loops are doing, because we're executing that task n number of times, and so we have all of that overhead associated with the task. And in fact, if you configure 100 VLANs using a loop versus a method that I'm going to show you in a minute, we're talking about several minutes, probably 5 to 10 minutes worth of difference using loops versus trying to send everything as a single transaction. So let's wipe this out, and let's do this a different way. So instead of using an Ansible loop, I'm going to define a Jinja2 variable. It's called, I'm going to use the setFact module. Anybody use setFact before to save data? Fantastic. Okay, so using setFact, I can actually save my data and use a Jinja2 template to loop over the same information. So you can see here that I'm looping over that VLANs.j2 template, and I'm pulling the data from my group vars, but I'm using a Jinja2 template to create that payload in memory and then save that into that NXOS VLANs variable, and then I can pass it as a single transaction without having to use a looping mechanism. So this is an example of going through and looping through all of those. And finally, when I save that, you can see that in blue there. When I save that Jinja2 generated payload into my NXOS VLANs variable, I can pass it directly into the NXOS VLANs module and do all that as a single transaction. And I'm telling you, it's so much faster to do it this way. So that's another best practice. Now, not all of the modules allow you to do that. So there are legacy and what we call resource modules within the NXOS collection. So if you started very early with Ansible, most of the modules you were using were legacy modules. They supported states like absent and present, and they only dealt with a single instance of a particular resource. So you still had to loop. So I'm not saying looping is bad, because in some cases you still have to loop. But with the resource modules support bulk transactions. And another nice thing about the resource modules is that they're developed by Red Hat across multiple vendors and multiple OSs within a vendor. And so they're more consistent. They try to develop more of a common interface for these modules, and then they support a set of common states. More advanced states than absent and present. As an example, one of the states they support is a state called overridden. So if we think about the VLANs module, very simply, I'll tell you that if you define the data for your VLANs and you call it with the NXOS VLANs module using state overridden, what it's going to do is it's going to use your playbook code as your source of truth. So if it finds any VLANs that are not in your playbook source of truth, it's going to purge those VLANs from your device and replace it with your source of truth in your Ansible playbook. The absent and present states don't do that. So it starts to move this idea of using Ansible as your source of truth for your network devices. Make sense? All right. Another module I want to reference is the config module. Now, we call this the fallback module because if you don't have a resource module for a particular feature, you can use the NXOS config module because it just sends straight CLI commands to the device. In practice, I find this module to be very popular. A lot of our customers like to use this module because it's a lot closer to the CLI, which many network engineers know and love, and so this is a very popular one. It also provides the capability of taking a full backup of your running configuration, and then you can also save changes. So you can do a copy run start based on different settings in your device. And so these are some of the different triggers for when you would save those changes or perform a copy run start. The other module I want to talk about is the command module. So this is another good module if you want to get state from your devices. You can use show commands, save that state into a variable using setFact that we talked about earlier. And this also allows you to handle prompting. So the other day, I was actually working with someone in the company. They wanted to know if we could support dual stage commit. I don't know if you've ever used dual stage commit on NXOS devices, but there's some additional prompting in our modules. The modules in this collection don't natively support that feature. So I was able to use the NXOS command module to handle the prompting for that dual stage commit feature. And so that's a nice option. So it's essentially, these are two stopgap modules for you if you need to make progress and you don't have a resource module for that. All right. So we kind of come full circle, and we talked about, let's recap what we talked about. We talked about, in our EVP and VXLAN example, we needed a bucket for common configuration, we needed a bucket for underlay configuration, and we needed a bucket for overlay configuration. And so we took that and we defined highly reusable roles. Now, this is just a full example of running an Ansible playbook. Ansible playbook-I, inventory.yaml, vxlan.yaml. Remember, inside inventory.yaml is our spines and our leaf devices. vxlan.yaml has the entry point into all the code to configure an entire VXLAN EVP and fabric. In the slides, we have a QR code where you can connect to a repo where we have a full example of this. So I just showed you a small subset just to kind of go through some of those concepts. But this is an example of that automation running with all the configuration data you need to configure a full VXLAN EVP and fabric. Okay. So we're going to take this idea of this data model-driven approach. Now remember, we defined our data model, not our data model, we defined our data in host vars and group vars. But now we're going to kind of take this and kind of hit the turbocharge button, and we're going to look at how do we manage a VXLAN EVP and fabric using NDFC in Ansible, and then kind of, start to model this idea of infrastructure as code. Well, as I mentioned before, NDFC has now been rebranded. It used to be called DCNM. While the GUI is extremely powerful, right? Before you write a single line of automation code or Ansible automation code for NDFC, it already gives you a lot of automation out of the box. It allows you to create what we call a fabric object in the GUI. That's where you define a lot of your fabric settings. And then by simply adding devices to that fabric and selecting a role, think of like a spine role or a leaf role, based on that role, it will apply all the best practices CLI configuration using the baked-in templates in NDFC. It'll auto-discover those devices, and you can bootstrap an entire VXLAN EVP and fabric using NDFC in minutes. So I think this gentleman here said it was 2 weeks to do that manually. With NDFC, you can be up and running very, very quickly. And obviously, there's very complex fabrics, and so working with NDFC, there's certainly complexities to that as well. But it also provides a very rich northbound REST API that you can start to develop your playbook code, or you don't have to use Ansible, but we're talking about Ansible today. But when I talk about something that's DevOps friendly for NDFC, what do I mean? Well, earlier we talked about installing the Ansible core engine, and then we had two additional collections. We had the DCNM collection and the NAC DC VXLAN collection, the solution collection. So using those two collections, we can actually program via the northbound REST API, not using ClickOps in the GUI, but via the northbound REST API, we can start to do the same things that we would do in the GUI, but do it through Ansible automation instead. All right. So let's kind of walk through our VXLAN EVP and use case, but let's walk through it from an NDFC fabric perspective or an NDFC product perspective. So in the NDFC GUI, the first thing we do, if we were going to do this in a GUI workflow, we would actually create the fabric object, and we would define our underlay properties. We would define our bootstrap properties. Do we want to bring devices into the fabric using POPE? Do we want to use pre-provision workflows? Do we want to use a discovery workflow? The VPC properties, the different protocols that you want to use, resource ranges, all of this is defined as part of the fabric object. Once I have a fabric object, now I need to start adding devices to my fabric. I want to add a couple spine devices. I want to add a couple leaf devices. I want those devices to automatically discover each other and configure themselves based on the role that we selected. Next step, I may want to put a couple leaf devices into a VPC pair. Now, obviously, with any VXLAN EVPN fabric, we've got to configure a bunch of interfaces. I'm not going to cover that here. We're going to assume that we have to configure interfaces, but I'm going to move directly to the overlay pieces, the VRFs and VLANs or networks that we want to configure to enable that east-west traffic. Now, the building blocks that we have to do this, there's about 19 modules in our collection. But we're going to kind of zero in on the primary modules in that collection. You can go, let me just go back to that URL right there in Ansible Galaxy. It has all the documentation for the 19 modules that we support. But these are the primary VXLAN EVPN fabric plugins that we're going to focus on today. These are the building blocks for creating a VXLAN EVPN fabric with Ansible. So we have a DCNM fabric module. Just like the name says, that's what we use to create the fabric. And these are kind of called in the same order, right? There's an order to these things. Then we want to add devices using our DCNM inventory module. Maybe we want to put something into a VPC pair within our fabric using the VPC pair module. Obviously, we want to manage interfaces, like I said, so we have an interface module that manages all the different types of interfaces. You want to put things into access mode, trunks, port channels, VPC interfaces. This module supports all of that. And then we have the two workhorses for our overlay configuration, the VRF and network module. And then nothing would be complete without being able to configure policy. And so this is where you can do some of your route control if you want to do an L3 out or VRF light and apply some of the BGP policies for route control. You can do that with the DCNM policy module. All right, so these are the building blocks or the Lego blocks for using Ansible with NDFC. So let's build something now as net DevOps engineers for NDFC with Ansible. So getting back to that first step, this is how we would create a fabric in the GUI. We would just go in and do actions, create fabric. We would give it a fabric name. We would specify the general parameters, replication parameters, VPC parameters, all those things along that list. The only required piece, though, to create a fabric is the BGP AS number. You can use default values for everything else. So how do we do this in an Ansible playbook? Well, this is kind of the old way, so let's talk about the old way. I'm going to talk about a new way in just a moment. But this is using the building block directly, right? So remember earlier we talked about the different roles we had for direct-to-device workflows. We had a common role, we had an underlay role, and we had an overlay role. Now our roles look a little bit different because we're dealing with NDFC, but these are still functional roles. We have a create fabric role, we have an add inventory role, we have a setup VPC role, right? We have a manage overlay role. So in this particular case, we are using the DCNM fabric module and passing in the key value pairs. So we have a fabric name, we have a fabric type, VXLAN EVPN, we have a BGP AS number, because I said that was the only required property we needed to create a fabric. And then we have an Anycast gateway MAC, and I'm saying that I want to use a v4 underlay, not a v6 underlay. So first of all, remember from before, like, what's the problem with this task again? Remember? Hard coding things, right? I don't want to hard code things in the task like this. I don't want to do it this way. So there's a better way. Now, we're not going to talk about the same thing that we did with NXOS. I'm going to introduce this idea of VXLAN as code, where we are driving everything with a well-defined, opinionated data model for VXLAN EVPN fabrics when you're using Ansible automation with NDFC. So what is VXLAN as code? Well, I just said a little bit of what it is. It's an opinionated data model that allows you, the DevOps engineer, to work with the data model, and you don't have to worry about the building blocks any longer. So you don't have to put all the pieces together and glue them together in the right order, because we are taking care of that for you. All you have to do is update the data model, and it will push those changes into the fabric. If you remove things from the data model, it'll remove those things from the fabric. Not in every single case, but in certain cases. And so you can focus on the intended configuration instead of worrying about putting all the automation building blocks together. So here's a case. In fact, I'm going to show you right now. We've got this URL, https://netiscode.cisco.com. If you go to that URL, obviously this is more of a part. This starts to show you different parts of the data model. So we've got this data model available out there to describe your VXLAN EVPN fabric. You can start clicking into the different pieces. So if I want to look at networks, for example, it provides all the different structure for the model. It provides all the different key value pairs. It provides default values if a default value is applicable in that particular case. And so we've already defined this data model for you, and then now we've written some Ansible automation in our solution collection that will consume this data model to configure your fabric. So this data model, this is a small snippet of the underlay portion here. So this data model is written by network engineers. So it's partnership between the data center BU or the BE and CX to write features into this data model that incorporate best practices for VXLAN EVPN fabrics. So when you build something on top of a data model, it makes validation easier. It makes input validation at the beginning of your workflow and at the end of your workflow in terms of writing tests for your network state. And I'll show you a little bit more about that in just a moment. The way that we validate our model data is we use something called Yamale. I've got a pointer to Yamale there, but that's how you define a schema for your data model, and then you can use that schema to do input validation, which is a really important piece, so you can start to validate things before you ever try to go and configure your fabric. We also support default values. So if you define something in your data model data, you may not want to define all the pieces, so we automatically insert default values for things. So here's an example where I want to configure some VRFs. I've got one called Cisco Live, one called BlueNet, and I want to insert the loopback route tag and VRF MTU automatically. And so those will be automatically inserted into that data before we try to configure that intent in our fabric. Now, if you don't like the default values that we supply with our solution collection, you can provide your own. And it's as simple as just dropping those custom default values into host vars, because host vars, remember we talked about that, that's a directory structure where you put your data. We drop it into host vars, and we can use and override the default values with your custom default values. All right, so there's two ways you can work with this collection. Way number one is most of it is open source. You can just install it from Galaxy and start working with it. We provide, in fact, in the slides, I provide an example repo for you to get started. But you can also take advantage of some enhanced services from the CX organization or the services arm at Cisco, where they provide the schema that we were talking about. They provide some additional custom rules. We've already written some base rules that make sure that the data that you're passing in is mostly functional, but you may want some custom rules based on your organization's need, and so we provide that capability as well. So you can write your own custom rules, or you can use CX services for them to help you write these rules. They can also help you build CI/CD pipelines, and they can also help you with testing and validation. Right? So you use the same data model to configure the state of your fabric, and then that round trip using that same data model, you can write a series of tests to validate the configuration state of your fabric. All right, so one very, very important part when we start to move towards a data model-driven approach is this idea of pre-change validation. I don't know about you, but I would rather know that my data is bad or good before I try to configure my fabric. And so that's what this pre-change validation step is all about. So this is where I determine if the format of my data is correct based on that schema. I verify the syntax, the semantics, and then also compliance with my particular organization's objectives for my network fabric. So this gives you a lot of flexibility, and I'll show you in just a moment how we do this through Ansible and a special role that we call validate. Okay, so here's the VXLAN as code building blocks, and this is where we start to move towards what does this look like in Ansible. So automation objectives that are super important, right? We want to be able to do input validation and rules validation or semantic validation before we ever touch the controller. We want to enable better testing. We want to be able to enable our solution automation into a pipeline, and then potentially also integrate with some type of chat ops agent so that we can notify when my automation is done, what the status result is, how many of my tests passed or failed. So we provide a lot of this already in the example repo. We provide examples for you to integrate with your own chat ops agent, but using the services arm of Cisco, they'll help you build out CI/CD pipelines. But the point of this is that the solution data model that we are developing here enables a lot of these objectives because we have a well-defined structure now. And so we take this data model data organized in YAML files. And by the way, you can organize your data in these YAML files however you want, because that's what you're interacting with. You're not interacting with all the different modules and plugins anymore. You're interacting with this data. So you can organize this data as long as it follows the model structure that we have defined. For example, I have one interfaces.yaml file here. Well, what if I wanted to break that up and put all of my access interfaces into one YAML file and all of my port channels in a different file and all my trunk interfaces? So you see that you can start to segment this out. As long as it follows the well-known structure and schema, you can organize data however you want, and we'll consume this data and apply it to your fabric. So how do we consume that data? Yes?
What happens with a conflict if you have twice the same?
Yes. Yeah, so the question was, what if you have a conflict? What if you have two of the files? So it's a very good question. So right now, if you define the same key in more than one places, there is a danger of that file being overwritten by the other definition of that. And so I'm working with the team to look at some ways that we can detect that and actually error out early in that process, but very good question. Okay. So how do we process this service model data or this structured data? So we've written 4 roles. So up till now, we've talked about Ansible roles as really more functional roles. But now what we have operational roles because we're acting on the service model data. So we're consuming that service model data and we're validating it first with that validate role. Then once it passes the validation stage, now we're going to take that same service model data and we're going to create the state or objects with the NDFC, and we're going to stage that in NDFC. Once everything is created and staged, then we're going to push that configuration to the fabric devices using the deploy role. And then finally, we run our remove role, which looks at anything that you've removed from the data model. Because remember, the data model now is your source of truth. So if I remove a VRF or a network or a VLAN from my data model, and I find it in NDFC, then I'm going to remove that thing. So that's how you start to move all of your source of truth into this data model, and you can start to see how you can build a CI/CD pipeline with that being your source of truth. Now, there is some dangers in that remove role, and I'll cover those in just a moment. All right, under the covers, right, so everything sits under the data model. You've got the 4 roles. Under that are all the building blocks that we've been talking about. Our base collection still drives this configuration intent into the fabric, and those green modules, or the modules that I've colored in green there, use the northbound REST API of NDFC to program your fabric. But again, you don't have to put these pieces together yourself. Okay, so what does the main VXLAN.yaml file in our Ansible directory structure look like using the solution collection? Well, now we have these 4 operational roles, not these functional roles, that process the data model traffic, or the data model data. In this case, I'm configuring 2 different fabrics. I'm no longer going direct to device. I'm configuring an entire fabric that fans out to devices. In this case, it's 2 of them. And we can do it in parallel, which is a nice aspect of Ansible. If you put 2 fabrics side by side like that, it'll go out using the data model data for each individual fabric and create the entire fabric for you. This is the inventory file, so this is how we define the NDFC. In this case, I just created a group called NDFC because my credential information to access and log into NDFC is the same. So I put everything under the same group var called NDFC. And then I can put a connection.yaml file under my group vars under that same NDFC keyword to define the credentials for how I want to connect to NDFC for my solution collection automation. So a couple differences you can see here. We're using the Ansible connection called netcommon.http API. This is the general plugin in Ansible that you use for all REST interfaces. But we've written our own flavor underneath that, and that's defined by the Ansible Network OS. So cisco.dcnm.dcnm says use that REST plugin, but do it specifically for DCNM. And so we wrote that as well as part of our base collection. And of course, we have the username and password. In this case, I'm using HashiCorp. I'm sorry, we're using just Ansible Vault to encrypt the password, which is also a best practice. Earlier, I showed a clear text password, but wanted to show you both. First one was a no-no. This is the good way to do it. And you might have a different NDFC switch password. So the credentials you use to access NDFC might be different than your switches, and so we provide variables and expose those using environment variables, so you can just set an env variable to access the different pieces of your fabric. Okay, so let's get back to our data. Remember, we're using our well-defined data model now, so you can see that under host vars, I have a directory name for my two different fabrics. But you can see that I have the same file name, global.nac.yaml, under each. So they have the same data that follows the same structure, but the values are different, right? So I've got a different fabric name in each one. I've got a different BGP AS number, different number of route reflectors, a different Anycast gateway MAC. So how do we process this data? Going back to our use case, I'm going to actually skip over the slide because I already touched on this earlier. But by the way, if you guys want to scan that QR code, this actually brings you to our service model data. So I'll just pause there a moment if anybody wants to scan that. But it'll be in the slides as well. All right. A couple of people scanned it. So if we go back to our step of creating a fabric, how do we do this with our service model approach? Now, remember, I don't need to worry about the Ansible building blocks anymore. I just need to worry about the service model data. So I define my service model data here under host vars for NDFC Fabric 1. And now I start to process that data. Everything is under the VXLAN root key because all of our data model data is under that VXLAN root key. Now I start to process this data through my different roles. So what do I do with this fabric data when I'm processing my when I'm creating my fabric? Well, first of all, I validate the VXLAN.global fabric data against the model schema if I have a pointer to one. I don't have to have a model schema, but that's how we provide input validation. One example of input validation in this case would be, is my MAC address correct? Is it syntactically correct? If it's not, my validate step will exit early saying there's a problem with this MAC address. Also, at this stage, in this Ansible role, we've created some base rules. So as an example, there's some restrictions between spanning tree VLAN and MST ranges. And so if there's a problem in this area in your data model, we have a rule that will catch that, and it'll fail early. Again, we want to fail before we ever try to configure the NDFC fabric through the NDFC controller. So once we pass the validate stage, this is where create takes that same model data and we transform that data. Remember we talked about Jinja 2 templates earlier as a way to transform data? Well, we actually use Jinja 2 templates in our create role to transform the service model data into the data that's required by one of our building block modules. In this case, it's the Cisco DCNM Fabric module. And we use that to create and update settings in our fabric. And then finally, once those changes are staged, we deploy those changes. Now, With the fabric piece or the fabric part of the workflow, we don't really deal with remove, so I'm going to move on to another use case where I can detail how remove works. So step 2. Now we want to add some devices to our fabric. So how do we do that with our new service model data approach? Well, the way that we do that, well, here's an example of how we would add it in the GUI for those of you who have never done this in the GUI or have. You know, you go under Add Switches, you specify your switch credentials. There's also a lot of steps, right? There's like 1, 2, 3, 4, 5, 6, 7 steps in the GUI, which is great, but we don't have to do ClickOps when we're doing automation. We can just do it very efficiently with this data model and define all of our switches and the roles in one single place under VXLAN topology switches. And then this data will be processed by our 4 roles. So validate will make sure that that data is, correct based on our service model. It'll provide some input validation. And then one of the rules that we define, and this is, you might say, well, why can't you do this in the schema? The serial number is required for a switch. Because of the way that Yamale works, there's some inflexibility with it. And so what we've done instead is we've written a base rule to ensure that you have a serial number for every single device. And so if we didn't have one, it would fail at this step. Then we process that through create, so we would stage that configuration in NDFC, but we wouldn't push the configuration to those devices yet. We do that in the deploy role. Now, I do want to mention that each of these roles can operate as standalone roles. You don't have to operate all of them. So if you just want to run the validate role against your service model data to make sure everything looks good and everything is syntactically correct, you can do that. So you can kind of pick this stuff apart and build different pipelines for this stuff if you wanted to. Now, this is where remove gets interesting. The way I remove a device from my fabric is I just go comment it out in my data model file, and the remove role will remove it. Now, we know this is dangerous. We know that if you're just testing, you install this collection for the first time and point this at a live production fabric, which I would never recommend under any circumstance you ever do. But if you happen to, you don't want to inadvertently remove something because you didn't define it in your data model. So we do provide a safety flag. By default, safety flags prevent removal of anything in your fabric, and we default those values to false. So you have to explicitly turn that feature on if you want to remove something from your fabric. So just as an aside. All right, next step, we want to put something into a VPC pair. I'm not going to go through all the roles again for each of these last steps. This is how we would actually put something into a VPC pair in our GUI. We would select the leaf device, and we would go under VPC pairing. For our service model, this is the section of the model that deals with VPC pairs. So you can see we've got peer 1 and peer 2. Those are different leaf devices in my fabric. And then I can specify the physical link between those devices. I can also use a fabric peer link. We support that capability in the data model as well. And those get processed through the validate, create, deploy, and remove roles again. Final step, dealing with the overlay. Layer 3, layer 2 VNIs. How do we do that in the GUI? Well, we go into the create VRF and create network pieces. Very efficient to do this in our service data model. This is an example of creating a network. And again, it's under the VXLAN overlay. Now, I will say this. If you go double check me, you're going to see that in the data model today we call overlay services. We thought that was kind of confusing, so we've actually updated it, and we're about to push that change, so I updated the slide. So we're actually putting networks and VRFs under the overlay keyword instead of overlay services. But when you define a fabric, this is how you decide where you want to attach this particular network. So you define an attached group, and then you give that name to the attached group, and you can put any number of leaf devices in this. And by the way, just by changing the names of your attached group or changing the number of devices, you can remove and add attachments, again, just by making changes to your service data model. Yes, question?
If some feature is not supported by NDFC or DCNM, for example, how we can resolve this problem with Ansible, with DCN-M?
Yeah, great question. So the question was, if there's a feature that's not supported by NDFC or DCN-M, how can we resolve this problem with DCN-M or Ansible, right, with NDFC?
We can resolve this problem with Ansible and NXOS, of course, because
Yes, yes, right, right.
what we can do in this situation with Ansible and DCN-M.
So there is a feature, there is a capability that I'm not covering in my session today. I did talk about one of the building blocks, and that's our policy building blocks. We do provide a way for you to define your own policy and bring your own policy. And you can define whatever you want. So you can actually pass any CLI configuration using policy into NDFC. And so we actually provide a way to do that in our collection. So we define a place in the data model where you can just kind of drop your own policies in, and we'll consume those as well. Now, there's also features that we're baking into the data model. So we're working, for example, the VRF-like capabilities on NDFC don't have as much flexibility as we would like. So what we did is we actually built out a data model, and then all you deal with is the well-defined data model for VRF-Lite, and then we map that to templates and policies on the back end, but that's completely transparent to you. So we have two ways. You can bring your own policy, or you can use some of the additional features that we're creating that map to policy on the back end. Yes, questions? Sorry? Yes.
Is it something to do with a switch freeform that we can integrate in this particular part, or not really?
So, yeah, that's a good question. So he was asking if we can actually use the switch freeform and integrate. So we are looking at exposing some of the freeform capabilities within our data model, so you can actually make use of that feature in NDFC as well. We don't fully support that today because we need to do some additional testing, but we are exploring that is on our roadmap. Yeah. Another question over here I saw? Okay. All right. Fantastic. All right. So I just want to take a bit of a deeper dive into the Yamale schema validation. Remember I talked about the fact that if the Anycast Gateway MAC was invalid, this is an example of the error that you would get from the validate role if that was not a MAC match. So obviously, I've got an incorrectly formatted MAC address there, and so it would detect that early before we ever go to NDFC. If we have a base rule that also cross-references the VRFs and networks. So you can see in this case, I've got a VRF, NAC VRF1 that's commented out, but I'm referencing that in my network. And so my validate step would actually run a rule to check this. It's called semantic rule 401, and it would generate an error saying, hey, you defined something in the data model that I don't know anything about. And so we do some cross-referencing that way between the different parts of our data model. So we use group vars. And when you use our example repo and install this and start working with this collection, you'll actually see the sac.yaml file under NDFC. This is where you point to the schema path or any enhanced rules. Again, this is if you're working with the services arm or you write your own custom rules, this is how you would actually point to a schema or a set of enhanced rules that go beyond the custom rule or the base rules that we provide with the collection. And then, remember I talked about those delete control flags? Those are all defined in our example repo. They're defined in this ndfc.yaml file under group vars. I've turned them all to true, but by default, the collection in the role, like deep in the role, actually defines all these and defaults them to false. One additional piece that I haven't talked about is this force run all parameter. So if you set force run all to true, it runs every single section of every single role. If you set it to false, it tries to intelligently determine what parts of the data model have changed and only run those parts of the automation. For example, if I only add VRFs or only add networks, I don't want to manage interfaces and fabric and VPC pairs and all that stuff. I just want to run the VRF or network section. So that's what that flag controls. And then finally, we have one additional execution control mechanism we've made use of tags throughout the collection to help you control execution. So if you want to just run a specific role without having to comment out some of your playbook code, you can just pass in a specific tag and control execution that way. And so if you use this command here and say -tags role star, it'll dump out the list of tags that we support for this collection, and then you can pick and choose what you need based on your execution needs. All right, so we have about 20 minutes left. So I want to actually demo this stuff working so you can get a better idea of what it looks like. So let me switch over here to my GitLab environment. Okay, but before I do that, I'm going to log on to NDFC. And I'm just going to show you kind of the current initial state of my NXOS Dashboard Fabric controller, just so that we can all be on the same page, assuming it actually connects. Make sure I'm on the VPN. It's always fun doing live demos. I'm sure it's going to connect. There we go. Starting to come through. All right. Okay. While I'm waiting for that to actually load up, let me actually show you the GitLab repo and kind of how I've structured things. So here's my GitLab repo. I've taken the example repo, and we actually just cloned it into this GitLab repo environment. And so you can see here that my starting point here is these are the different roles that we talked about: create, deploy, remove. Now, what's missing from this playbook? What's that? Yeah, or validate, right? Yeah, validate, right? So I'm missing the validate role there. So a little tidbit, the create, deploy, and remove role actually call the validate role as a dependency. And so you don't have to explicitly specify it in your playbook. It'll actually automatically call the validate role, because the validate role is where we actually process the data and put that data in memory so that we can actually use it in our Ansible playbooks. So the other part of our repo is the host vars data. So host vars is where we define all of our different model data. And so I've organized it into these files. Again, I could organize it into different files depending on my needs, as long as it matches the model schema. And so what we're going to be dealing with today is we're going to be dealing with VRFs and networks. So you can see here I've got all of my VRFs defined, and along with my VRFs, I've defined my attach group. So I've got one that's attaching to all of my devices, or I've got one that's defined for all of my devices. In this case, it's just leaf 1 and leaf 2. And then I've got different attach groups for the specific leaf devices. All right, okay, so my NDFC did load now. So let's actually go look at this particular fabric. So you can see my fabric has 2 spine devices and 4 leaf devices, and everything is currently in sync. Let's see what networks and VRFs I have. If I sort these again, I've got net 1 through 5. If I look at my VRFs, I've got VRF 1 through 5. All right, so how would I add a VRF through my VXLAN as code solution and enable my pipeline to actually drive this change? Well, since I've got this in GitLab, what I do is I come into my IDE, and I'm going to open up the web IDE. It's actually really nice in GitLab because it opens up a VS Code environment, and I can actually make changes directly on my GitLab repo through VS Code. So I come in here, and I'm going to comment out net 6, and then I also want to add a VRF. I'm going to call this VRF 6. I'm going to save those changes. Now, I'm about to commit and push these changes to main. I wouldn't typically do this in a real pipeline, but just for the sake of the demo, I'm pushing directly to main. I would usually push to some safe staging environment first and test those changes before we go to production. But just for the sake of the demo purposes today, I'm pushing directly to main so I can show you how these roles process our service model data to make changes to our fabric state. So I'm going to add a message here. I'm going to say add. Can everybody see that okay, or should I make that bigger? Is that better? Back of the room? Okay, good. So I'm going to add VRF06 and net06. So I'm going to commit and push that to main. So committing and pushing that to main, because I'm in a GitLab environment and I'm using CI/CD pipelines, I have a pipeline defined that when it triggers, when it detected that push event, it triggered a runner to kick off a pipeline to push these configuration changes to my fabric. So let's go look at that. So if I go over here, I need to make that a little bit smaller because I've lost my build environment. So if I look at my pipelines, you can see that I have a pipeline running. So what's interesting about this is I have a validate step that ran. That was it actually ran the validate role to do my semantic and input validation on my data model. But you notice that it's paused, right? So this is intentionally put into our pipeline as a user intervention step so you can go look at the validate role results and make sure that there's either a green check mark. You can go into the logs and look at the specifics in the logs. Make sure that everything looks good before you deploy these changes to the fabric. And just so that you know that I'm not lying to you, I'm going to refresh my VRFs. I'm going to refresh my networks. And you can see that there is no net6 in my fabric. So now I'm going to go ahead and go back to my pipeline. And you can see there that that was my commit message. So I'm going to go ahead and push run here. And that's going to kick off a job that's going to go deploy these changes to my fabric. So what's happening now is it's actually grabbing a container that has the Ansible binary in it, and it's actually running our vxlan.yaml playbook, because it's using Ansible inside the container to run that playbook, and it's targeting that fabric. Now, you probably saw that validate ran again, right? Remember I told you that when you run create and deploy and remove, it automatically runs validate? So I ran validate once already, and we've done some massaging of the validate role so that some of the things that run in the first time we run validate don't run the second time we run validate. But it's basically going through all of the different pieces of our solution automation, and it's consuming that service model data, and it's building the payloads so that we can use those underlying building blocks in Ansible, the core Ansible building blocks in our base collection, to configure the state of the fabric. So that's what vxlan.common is doing. So right now, we just reached the create stage, so we're managing the fabric settings because it goes through all the different phases. Again, if we used that diff run flag, we wouldn't necessarily run everything. Now we're managing the fabric devices, and in just a moment, we're going to get to the point where we're adding VRFs and networks. All right, so that's where we are. So now we should start to see some changes to state. And you can see here that net6 is being added to our fabric. So it's in this pending state. Remember, it's going to stay in the pending state during the create role because we're not going to deploy these changes to the fabric until we get to that deploy role. So if you just wanted to pre-stage everything, you could just call the create role. Because some customers like to go in and actually pre-stage everything and then go into the GUI and click deploy. So that's an option if you wanted to. But if you want to do everything in an automated fashion, you basically just call all the different roles. So once we hit that deploy role, it goes into this deployed state. So I'm going to move over to the VRFs piece here. I'm going to refresh this. And you can see that VRF6 is now also configured and deployed. So this shows you just a small aspect of how we consume that service model data to push changes into our fabric. And all the different aspects of the data model that we support are processed by these 4 roles. So adding switches to the fabric, putting things in VPC pairs, managing all the interfaces, applying policy, all of that is defined and capable in our automation, in our data model today, and so they can be processed by these 4 roles, and you can use that to manage the fabric. Okay, so I do want to show you just one additional piece, and then we will stop here, and if you have any questions, I'll be happy to stick around and answer additional questions. But if we look at the pipeline file, so this is the GitLab CI file. So I want to show you this. These are the pieces that we're defining, how we define our pipeline. So you can see that the validate stage, it actually runs this validate.yaml file, which only includes the validate role. So that's all we're doing there. Remember I told you before that you can kind of pick and choose which of these roles you want to run. You can run them all together, or you can run them in isolation. We're isolating the validate role, and as part of the validate stage, we're only running that piece. When we get to deploy, you can see here that, remember that manual intervention where it says it was blocked? That's how we do that. We say when manual, so that we pause for user intervention. So until the user inspects those validate results, we don't allow the automation to continue. Now, remember I talked about testing. So one of the things that we get with this is a bunch of testing as well. So let me go back here and I'll show you when my job got done. Now, the testing is not done in Ansible. It's actually done in Robot, but this is part of the services arms of Cisco. But you can see here that I had 96 tests that ran to validate my configuration state. So there's all of my different networks, there's all my different VRFs. So the data model state is used to drive my tests at the very end of deploying my state to my fabric so I can validate that configuration state. Now we're also looking at potentially adding operational state validation as well, but right now it's just configuration state validation.
Would we see details of any test?
Yes, yes. Yeah, so if I go into the artifacts, so one of the things that we can download is an artifacts file here. So let me download that, and then I open that particular file, unzip it, and then if I go into the test results, NDFC, and I look at the log.html, so now you can actually see some more of the details for these particular tests. And so everything is basically written in Robot, and so what the tests do is they go in and they use NDFC URLs to query the configuration state, and then the state that comes back from NDFC, they validate that using Robot tests against the configuration data in the service model. So they use the service model to validate the state that comes back from NDFC inside of this test framework. Okay. So that pretty much wraps up most of what I wanted to speak about, but before I close out, I want to get you some additional resources to continue your journey. So first of all, here are the QR codes for the VXLAN as code solution repo and the code for the example repo to set this up. So the example repo, when you clone that, it'll walk you through how you set all of this up. And then the stuff in the beginning where we talked about NXOS direct-to-device workflows, we have complete sets of code using the NXOS modules for setting up a VXLAN EVPN fabric using NXOS. And so we provide that repo for you as well. And then these are just some additional pointers to different Galaxy collections that we covered today and getting started links. Some additional sessions that you might want to check out today. I'm actually doing another DevNet session tomorrow. It's not on VXLAN as code. It's more dealing with the building blocks of NDFC. And then There's some additional information around VXLAN and NDFC in general that you might want to check out. All right, so please fill out your session surveys. Those are very helpful for us, and I will open it up now for any additional questions if you have any. If not, enjoy the rest of the conference.